Hello everyone, it's time for presentation of video lecture 9 of pavement construction, which deals with physical properties of aggregates. Let us get into the discussion as follows. Physical properties of aggregates. Aggregates are essential materials in construction, providing stability, strength, and durability to various structures. Let us dive into the physical properties of aggregates. Aggregate can be categorized into two main types: natural aggregate, which are obtained from natural sources like sand, gravel, and crushed stone, and artificial aggregate, which are manufactured from industrial byproducts such as sludge and recycled concrete. The physical properties of aggregate includes shape of aggregate, size of aggregate, texture of aggregate, porosity of aggregate, bulk density of aggregate, specific gravity of aggregate, absorption and moisture content, and bulking of aggregate. The shape of aggregate can be angular, round, or irregular. Angular aggregate provides better interlock, while round aggregate offers improved workability. Texture refers to the smoothness or roughness of aggregate surface. Roughness texture promotes better bonding between aggregate and cement paste, enhancing the strength of concrete. Density is another crucial physical property of aggregates, impacting the overall weight and volume of concrete mix. Higher density aggregates result in dense concrete with improved durability. In conclusion, understanding the physical properties of aggregate is essential for design strong and durable concrete structure. Whether it is selecting the right particle size, shape, texture, or density, aggregates play a vital role in shaping the built environment. Let's proceed to the effects of different physical properties of aggregate. The effect of aggregate on production of cement and asphalt production. The shape of aggregate particles used in cement and asphalt concrete production can have significant impact on the properties of final mixture. Here are few key points to consider. Workability. The shape of the aggregate particles can affect the workability of concrete mix. Angular and rough texture aggregates tend to interlock better with each other, which can reduce workability as more water may be needed to achieve proper flow. On the other hand, round aggregates may improve workability by reducing internal friction. Second, strength and durability. The shape of the aggregate can influence the strength and durability of concrete. Angular aggregates have a better mechanical interlock within mixture, leading to higher compressive strengths. However, round aggregate can provide better resistance to wear and tear in the long term. 3. Mix design. The shape of aggregate particles can also impact the mix design of concrete. The gradation, size, and shape of aggregate must be carefully considered to achieve the desired properties of final mixture. In some cases, desired properties of final mixture. In some cases, combination of angular and round aggregates may be used to optimize both workability and strength. 4. Asphalt concrete. In asphalt concrete production, the shape of aggregate can affect the suitability and performance of the pavement. Angular aggregate provides better interlock and resistance to deformation, while round aggregates may result in improved rotting resistance. In general, the shape of aggregate plays a crucial role in cement and asphalt concrete production, and influencing workability, strength, durability, and overall performance of the final material. It is essential to carefully consider the shape characteristics of aggregate when designing and producing concrete mix. This is the different types of aggregates. The first one is poor shaped crushed aggregate. This is not preferable to be used as a concrete, cement concrete or asphalt material. Here the second one is crushed cubical aggregate. It is much better than the first one. Let's see the second effect of size of aggregate on the production of cement, concrete, and asphalt production. When it comes to producing high quality concrete and asphalt, one crucial factor that must be considered is the size of the aggregate being needed or used. Aggregate are the fundamental materials in both concrete and asphalt production, and their directly impact the strength, durability, and overall performance of the final product. In concrete production, the size of the aggregate plays a crucial role in determining the workability of the mixture. Smaller aggregate tends to create a denser concrete mix, while larger aggregate can provide better resistance to cracking and shrinkage. When working with smaller aggregates, the concrete mix is easier to manipulate and pour, allowing for better finishing and detailing. However, large aggregates are commonly used in structural applications to enhance the overall strength and load bearing capacity of concrete. Similarly, in asphalt production, the size of aggregate affects the performance and longevity of the pavement. Smaller aggregates create a smoother surface suitable for high traffic areas with higher speed, while large aggregates offer better stability and resistance to wear and tear. The selection of the appropriate aggregate size for asphalt production is essential to ensure proper compaction and drainage. Smaller aggregates can help improve the overall skid resistance of the pavement, while larger aggregates are often used in mixture designed for a heavy duty application. Whether it is built a sturdy foundation or construction a reliable roadwork, the size of the aggregate used in concrete and asphalt production is critical factor that professionals must consider to achieve the desired performance and durability. Now let's see the effect of texture on effect of texture of aggregate on the production of cement, concrete, and asphalt production. In concrete production, the texture of aggregate plays a key role in determining the strength, durability, and workability of concrete. The shape, size, and surface texture of aggregate particles affects the bond between the aggregate and the cement. A smooth aggregate surface can result in reduced bond strength between the aggregate and the cement paste, leading to lower compressive strength and durability of the concrete. However, smoother aggregates can improve workability and reduce water demand in the mix. On the other hand, rough textured aggregates provides better interlocking with cement paste, improving the strength and durability of concrete. The rough surface increases the bond between aggregate and cement paste and enhancing the mechanical property of the concrete. In asphalt production, the texture of aggregate influences the stability, skid resistance, and durability of the asphalt pavement. The surface texture of aggregate particles affect the frictional property of the asphalt mix. Using coarse aggregate with a rough texture in asphalt mixture can improve resistance to rotting and moisture damage. The angular shape of the rough textured aggregate enhance interlock and stability and providing a strong pavement structure. In conclusion, the texture of aggregate plays a crucial or significant role in both concrete and asphalt production. Understanding how different textures affect of these materials is essential for designing high quality and durable construction project. Effect of porosity on effect of porosity of aggregate on the production of cement, concrete, and asphalt production. Porosity plays a significant role in both the production and performance of cement, concrete, and asphalt material. In the case of cement concrete, porosity refers to the presence of void space within the concrete mix. The void space can occur due to inadequate compaction during placement process, improper mix proportion, or the use of poor quality materials. The presence of porosity in concrete can have several negative effects on its performance. First, porosity can reduce the strength and durability of the concrete, as the void space provides pathway for moisture and chemicals to penetrate the material, leading to crack, spalling, and other forms of deterioration. Additionally, porous concrete is more prone to freezing and thawing damage, as water can enter the void space, freeze, and expand, causing stress on the concrete mix matrix. In the case of asphalt production, porosity refers to the presence of air void within the asphalt mix. Porous asphalt mix are designed to allow water to drain through the pavement surface and into the underlying layer, and reducing the risk of surface water accumulation and improving skid resistance. However, excessive porosity in asphalt can also have negative effect on its performance. High level of porosity in asphalt can lead to premature aging, rotting, and moisture damage. The void space in the asphalt mixture can trap moisture, causing the asphalt binder to deteriorate and lose its adhesive property. This can result in premature cracking and deformation of the pavement surface, and leading to increased maintenance cost and reduced service life. In conclusion, porosity plays a crucial role in the production and performance of cement, concrete, and asphalt material. Proper control of porosity level during the production process is essential to ensure the durability, strength, and longevity of the construction material. Now let us proceed to the effect of density, bulk density of aggregate on the production of cement, concrete, and asphalt production. The bulk density of aggregate plays a crucial role in both concrete and asphalt production. Let us dive into how these factors affect the quality and durability of this material. In concrete production, the bulk density of the aggregate influences the overall strength and workability of the mixture. Higher bulk density means more particles packed closely together and resulting in dense mix with improved strength. A higher bulk density also helps reduce the porosity of the concrete and making it less susceptible to water penetration and increasing its durability over time. Similarly, in asphalt production, the bulk density of aggregate affects the performance of the finished product. A denser mix with higher bulk density leads to better compaction and reducing the risk of rotting and improving the pavement's lifespan. The bulk density of aggregate in asphalt also impacts its resistance to cracking and fatigue under heavy traffic load. A well-graded mix with optimal bulk density ensure a stable pavement structure that can withstand years of wear and tear. Now, when we conclude, the bulk density of aggregate significantly influence the quality and performance of concrete and asphalt in construction projects. By understanding and optimizing this factor, engineers and contractors can achieve stronger, more durable and long-lasting infrastructure. Now let us proceed to the effect of specific gravity of an aggregate on the production of cement, concrete, and asphalt production. Effect of specific gravity of an aggregate is an essential and important factor that influence the property of both concrete and asphalt mixture. Specific gravity is the ratio of the weight of a material relative to the weight of equal volume of water. In the context of aggregate, it provides information about the density and strength of the material used in construction projects. In concrete production, the specific gravity of aggregate affects the overall density of the concrete mixture. Aggregate with a higher specific gravity will result in denser concrete, which can lead to increased strength and durability of the final product. On the other hand, aggregate with lower specific gravity may create lighter concrete with reduced strength. Therefore, selecting the right type of aggregate with an appropriate specific gravity is crucial for achieving the desired strength and performance of the concrete. Similarly, in asphalt production, the specific gravity of aggregate plays a crucial role in determining the quality of asphalt mixture. Aggregate with a higher specific gravity can improve the stability and durability of the asphalt pavement and making it more resistant to wear and tear. On contrary, using aggregate with lower specific gravity may result in a less stable asphalt that is prone to deformation and cracking under heavy traffic load. In conclusion, the specific gravity of the aggregate has a significant impact on both concrete and asphalt production. By carefully selecting aggregate with appropriate specific gravity, construction professionals can ensure the durability, strength, and overall performance of their concrete and asphalt structure. Now let us proceed to the effect of absorption and moisture content on the production of cement concrete and asphalt production. In the world of construction, the quality of the aggregate used in concrete and asphalt production plays a crucial role in determining the strength and durability of the final product. Absorption refers to the amount of water that an aggregate can absorb. High absorption rates can significantly impact the water-cement ratio in concrete, affecting its workability and strength. In asphalt production, excessive absorption can lead to stripping and premature failure of the pavement. Moisture content, on the other hand, refers to the amount of moisture present in the aggregate. Excessive moisture content can lead to problems such as reduced workability of concrete and decreased adhesion in asphalt mixture. It is crucial for concrete and asphalt producers to carefully analyze the absorption and moisture content of their aggregate. By using aggregate with optimal absorption and moisture level, producers can ensure the overall quality and longevity of their products. This is the diagrammatic representation of moisture in aggregate. Here we can see dry aggregate. Here is saturated aggregate, which is surface dried. This is the aggregate which is fully saturated, and finally this is the aggregate saturated and the outer part also covered with moisture. Now let us proceed to the effect of bulking of aggregate on the production of cement, concrete, and asphalt production. One important characteristics of aggregate that needs to be considered during production is bulking. Bulking refers to the increase in volume of aggregate due to the presence of moisture. In this discussion, we will explore how bulking of aggregate affects concrete and asphalt production. Effect of bulking on concrete production. In concrete production, the bulking of aggregate can have a significant impact on mix design and overall quality of the concrete. When aggregate absorbs moisture, it increases its volume, which can affect the proportion of the other materials in mix. This can result in decrease in the density of concrete, leading to lower strength and durability. Effect on asphalt. Bulking of aggregate can also impact asphalt production. In asphalt mix, the aggregate plays a crucial role in providing stability and strength to the pavement. When aggregate bulks up due to moisture absorption, it can affect the overall performance of the asphalt mix. The increased volume of aggregate can lead to inadequate coating by the asphalt binder and reducing the overall strength and durability of the pavement. Now let's see the mitigation strategy for bulking. Before we discuss about the bulking, let's see the bulking of different types of aggregates. This graph shows bulking of different types of aggregates: fine, medium, and coarse aggregates. Now let us proceed to the strategy to mitigate the effect of bulking. To mitigate the effect of bulking on concrete and asphalt production, produce, producers can implement several strategies. One common approach is to properly store and handle aggregates to prevent moisture absorption. Keeping aggregate in a dry condition and using it promptly after extraction can help reduce bulking. Additionally, adjust the mix design to account for bulking factors of aggregate can ensure the desired properties of the concrete and asphalt mix are minimized. In conclusion, the bulking of aggregate is a critical factor that affects both concrete and asphalt production. By understanding by understanding the implication of bulking and implementing appropriate measures to mitigate its effect, producer can ensure the quality and performance of the final product. Proper storage, handling, and mix design consideration are essential in managing bulk and achieve consistency and durable concrete and asphalt mix. This is all about for today. Thank you for your attention.